This is Fred. We're going to be doing project part 3 here. We're just going to be doing some of the lottery number manipulation again. We're going to be determining the top 5 numbers for each and then using a little bit of statistics with that. Okay, so we go over here to our MATLAB. We have this code here. We're going to query the data as we've done before, and this time we're going to set it up in MATLAB to select the functions so that I have a matrix full of data here for the data that I have in MATLAB for the lottery data. These graphs are again describing the distributions of the data, whether sorted or unsorted. And then we can see some of the distributions for the summation down here in the command window. So then we can look at our first objective, which was to determine the mean, the standard deviation, and the counts for each of the columns 1 through 6. So we can go back over here to MATLAB. Go ahead and close these. We don't really need them. Go to MATLAB. Run this section, which is just doing the mean and the standard deviation of each of the different columns. And we can see here, after going through our data, let's see, we have... Alright, so for our first column, the average is 9.6686, and the standard deviation is 8.24, meaning that we have a very low-sided distribution there. Most of the numbers are concentrated around 1 through 10, which, as we have seen in our previous sections of the project, is accurate in the distribution. And then N2 average is 19, and standard deviation of 10. Getting a little higher and a little higher, more standard deviation. N3 average is 29 or 30-ish, with a standard deviation of 12, getting even more spread out. As that standard deviation goes out, the more normalized or the flatter the graph is. That's how it correlates. So for N4, the average is 40 with a standard deviation of 11. And 5, the average is 50, standard deviation of 10, and 6, the average is 20, going back down low again with a standard deviation of 13. And so then for the counts, we have over here, we have created views in PostgreSQL. Open project 1. See, I've just added this statement where I'm creating and replacing a view of the data so it's easier to look at. I can go over here, and these are the counts of N1, and we can see that the top ones are like 1, 2, 3, 4, and 6. And then we can go through each of these, really, in N2, those are the top counts, N3, top counts, N4, top counts, N5, top counts, N6, top counts, and so on and so forth. So I've taken that data and I've put it into a matrix here, matrix M, and the next portion of the project asks us to, sorry, let me get that out of the way. So we have the counts, we have the mean and the standard deviation. Now we have to determine the number of permutations and combinations that exist if you only use the top 5 numbers for each column. So using the matrix and the MATLAB functions here, we can see that we have the permutation formula here, P, and the combination formula here, which is C. We can run this section, which give us permutations of that many, which is a very large number. Looks like 127 million or more. And our combinations, which are obviously less because the order doesn't matter, is 177,000. So then the next part of the project asks if the lottery had to use one of the top 5 numbers for each column, what is the probability that you'd win the lottery? And so that's just the basic combination problem. What you do is you would take 1 over the combinations for the total, so 1 over C here. That would be our percentage for total, and then we'd have yeah, this would be our probability of achieving or guessing correctly on the lottery. So then we go over here to using the MATLAB, generate 1 million random numbers to use only those found in the top 5, count for each column. Save these numbers and compare it to the next lottery draw. Determine if any one of your numbers was a winning number. Report your results. Now MATLAB can't handle 1 million, but we're going to use as many as it can handle. So what we've done here is just taken the length of it, shuffled the numbers that we have in matrix M from our previous one. Select 5 of those numbers at random, and that's going to be our selected one, and then we're going to run this and draw that 1 million times. So we can go ahead and run the section. So as you can see, it's having trouble to continue processing. That's because it exceeds the amount that you can get out of this. But our answer for the matrix that we selected was 24, 28, 31, 35, and 1. Now, since we obviously can't see this many, it'll be hard to determine whether it's going to win all the time or not. But we can see the numbers selected that have won on January 2nd of 2015. I think the most recent drawing that I was able to get is 35, 15, 62, 74, 13, and 12. Now we didn't win, obviously, but let's see if we actually did attain any of the correct numbers. So we can pull this over here so we can compare. 35, we got correct. But it looks like that was the only one. And we didn't select our Mega Ball one because that was not part of the formulation that we had in here. So if we close down MATLAB, hopefully it closes. Yeah, stop that exit because it wouldn't continue processing. I can open it back up and adjust the formula so that we don't have to consider 1 million, but we can consider at least a more suitable sized formula. So let's say we want 10,000. Let's go ahead and run that, and then set a simple equation to say 35, 15, 62, 74, 13, 12. Alright, we can select the last one. I don't know why it's doing that, but oh, it's not checking it line by line. Well, then I guess we could go through here and determine each one of the lines to see if we won any of the one of the lines. But that would take a long time to do by hand. But our answer of 21, 17, 15, 10, and 46 gives us, again, one of the selected answers was true. But we failed to get all 5 of them lining up with our 5 Powerballs without the selection of the mega ball, and so we fail this test to beat the lottery.